Okay, we are getting near the end with these videos. I'm sure you're so sick of them by now. And I understand it's not an ideal way to learn, so thank you for bearing with all these different videos and accepting this kind of strange format for the course under the circumstances. Our last topic is going to be the metric system. Okay, it's really a great system. It's just that in our country nobody uses it, so we don't have any familiarity with it, and it's strange to us. So it's not, we don't have a comfort level. And the rest of the world uses it. America and like 2 other places in the whole world don't use it. It's really weird. What makes it so nice though is that it's all based on powers of 10. Okay, if we look at kind of the 3 main groups of units that we may look at, length. In the metric system, length is measured in what's called meters, represented by the letter M. Okay, volume is in liters, letter L, okay, and mass in grams, letter G. Usually it's a small L, by the way. I put a capital L there. Okay? Alright, meters, liters, and grams. Okay, fine. So that's what we call the base unit. So that's kind of in the middle of our scale. Now we're going to draw a little scale of unit conversions. And meter, liter, and gram are right in the middle there, the base unit. Okay, let me just write that. Okay, now if I want to go a unit larger than the base unit, it's all powers of 10. So I'm going to move over to the left here, and the next little step over is called deca, D-E-K-A. Some texts call it D-E-C-A, deca. Okay, that means 10 more. 10 to the first power more than the base unit. So a decameter would be 10 meters. A decaliter would be 10 liters. A decagram would be 10 grams. So how would we say that? The abbreviation is DK, so DKM, DKL, DKG, deca. Okay? 10 more. 10 to the first power. Okay? Another step here. Hecto. Okay, 10 to the second power, or 100 times more. Okay, abbreviated H, M, hectometer. HL, hectoliter. HG, hectogram. Okay, so far so good. Kilo, another power of 10 over. 10 to the third power over. Okay? Letter K. So kilometer or kilometer, more commonly pronounced. Kiloliter, kilogram. Okay? Kilogram we have some familiarity with. Kilometer, kilometer we have some familiarity with. Okay? Alright, so far so good. So that's 3 powers of 10 away from our base unit, getting larger. Okay, a kilometer is a lot more than a meter, right? A kilometer is 1,000 times bigger than a meter. 1,000 meters inside of a kilometer. All right, what about the other way? Smaller units. The next one smaller now is called deci, D-E-C-I. Okay, and I'm kind of out of room right there. So that's 10 to the power of -1. Okay, and that's going to be abbreviated with a D. So decimeter, deciliter, decigram. Okay, next one is centi. C-E-N-T-I. We know that one. We definitely have some familiarity there. That's 10 to the -2 power. Okay, and we have centimeter. We use those. Centiliter, centigram. Okay, and then finally the next one is milli. okay? 10 to the negative third power. Millimeter, we have some familiarity there. Milliliter, we have some familiarity with that one. And milligram too, right? So that's pretty common even in our world. We use those units sometimes, okay, in the American system here. All right, so that's the base scale. Now it goes a lot more, milli. Then it goes in powers of 3. And actually, let me pull my book over for that. Okay, the book's organized a little differently than mine. Okay, now I have a lot of these memorized, but not all of them. Okay, just the first handful of steps, but this really doesn't show the base unit here. The base unit is right there, right? As we got bigger, we went to deca, hecto, and kilo. Well, think of the world of computers and things. A kilobyte used to be a big deal, but then it turned into megabytes, right? Now this is, each one of these are powers of 10, right? 10, 10, 10, but then it jumps in 3 times. So in other words, 10 to the first power, 10 to the second, 10 to the third, but then between kilo and mega, it's 3 jumps, all the way to 10 to the sixth, mega. Okay, megabyte used to be a big deal, but then it was gigabyte, 3 more jumps, okay, gigabyte, and now you even hear terabyte thrown around quite a bit, right? Another 3 powers of 10. Terabyte. I haven't really heard the other 2 in everyday language. Okay? On the lower end, okay, deci, centi, milli, those are all single powers of 10 shifts, but then we make a big jump from milli down to micro. Okay, we know that word, micro. That's another 3 powers of 10 smaller than milli. Okay, nano, we've heard that word probably, right? That's another 3 powers of 10 smaller. Okay, pico, femto, atto, each one of those is 3 powers of 10 smaller, okay? But this is the base scale here, from kilo down to milli. Oops, let me go back. Kilo down to milli, those are really the ones we're going to focus on converting in between. And you can see it's just going to be all powers of 10, okay? That's the nice thing about it. Okay, all powers of 10. Let's do a few conversions here. If I wanted to convert, I don't know, what should we do? Doesn't really matter. Let's turn, and I want to maybe keep this handy. How do I want to do this? I'm going to keep this handy for reference. Okay. Well, I'll pull it up as we need it. Let's convert, 3,495 liters. I want to convert that into kiloliters, into kilo, okay? Well, I'm here at the base unit of liter. In order to get to kilo, it's 1, 2, 3 places to the left. So I take my decimal point, which if it's not shown, it's at the end of the number, right? And I'm going to move it 1, 2, 3 places to the left. So 3,495 liters is the same as 3.495 kiloliters, okay? The unit conversions are so easy in metric because all we're doing is moving the decimal one way or the other. That's it. Okay, that's what's so beautiful about it. Okay, it's more of a logical way to do things. Okay, now I don't know where 12 inches in a foot came from, and 3 feet in a yard, and 5,280 feet in a mile. I'm sure there's great stories behind all those conversions, but they're weird, right? We know them now, but it's kind of weird. This is all powers of 10, just up and down the old scale there. Okay, let's just do that same 3,495 liters. Now let's go to milliliters. Okay, so I'm at liter, deci, centi, milli, 3 shifts to the right. Well, my decimal is already at the end of the number, so that means I'm going to be tacking on 3 zeros at the end. Milliliters. Okay? Then we can go back and put our commas in, right? You go back 3 digits and put a comma, comma. There should have been a comma here. Okay? So that would be 3,495,000 milliliters. Okay? Let's convert 27.6 centimeters. Let's convert that into hectometers. Why not? How many hectometers is that? Well, we find centi. We're going to go to hecto. 1, 2, 3, 4 places to the left. 1, 2 gets me there, so I got to have two leading zeros, 0.00276 hectometers. One little word of caution on some of these books, and this, my little book here included. You see, they don't really give, where I drew that black line, they don't really give the space there for the base unit. So if I were kind of careless and I was sitting here at centi to go to hecto, I would only count 1, 2, 3 places, because there is no place shown there in the middle. So I lost that place. All right. So we got to be really careful that we include the base unit in our calculation here. To go from centi to hecto, it's 1, 2, 3, 4. Okay. All right. Sweet. Let's go from 0.049 decagrams. I want to convert that into centigrams. Okay, what would that be? Deca to centi. 1, 2, 3 places to the right. 1, 2, 3 places to the right. 49 centigrams. These are, of course, equal, right? I'm not drawing equal signs here, but we're converting units. Same thing. Different unit of measure, but the same value. Okay? Alright, good deal. This is all pretty straightforward once you know the scale. Now, how much of that scale are you going to be expected to know? That's a great question. I would assume kilo down through milli you'd be expected to know. But other than that, beyond the milli on the small scale and beyond the kilo on the large scale, probably not so much, I'm thinking. Alright, if we want to add units together, let's do a couple more conversions, I guess. Let's convert, what should we do? I don't know, what have we ignored here? Let's do, I don't know, whatever. Let's do 5.25 kiloliters, and I want to convert that just back to liters, let's say. Okay, and I know, and I just caught myself, I'm not being consistent with my L's. Okay, some texts use liter as a capital L, and some use a lowercase l, so my bad there. I mean the same thing with all these L's, okay? They all are talking about liters. But let's convert kiloliters into liters. 1, 2, 3 places to the right. 1, 2, 3 places, so 5250 liters. Okay? It's all about decimal shifts when we're converting numbers. That's the beauty of it. Okay, what if we're asked to add some numbers, like 9 milliliters plus 2 centiliters? Okay, well, now we got to watch out here. We cannot add incompatible units. We have to make them the same unit. So it doesn't matter. We can make them both milliliters or centiliters. It's our choice. Looking at the scale, they're close by. It'd be a decimal shift one way or the other. So if we turn, for example, the 2 centiliters into milliliters, I would be shifting it to the right. So it would be 9 milliliters plus 20 milliliters. Oops, you can't see what I'm doing. And if I take 9 milliliters plus 20 milliliters, now it makes perfect sense, and I'm going to call that 29 milliliters. Okay? They must be compatible units, otherwise I can't add them together. Okay? How about 24.6 kilometers plus 38,000 centimeters. Okay? Well, that's weird. We need to have the same unit. Okay, 38,000 centimeters and 24.6 kilometers. We need to pick one. Pick them both kilometers. So in order to get centi to kilo here, I got to go 1, 2, 3, 4, 5 places to the left. So that decimal is going to go back 5 places. So 24.6 kilometers plus, I'm going to go 5 places. What did I say? 1, 2, 3, 4, 5 places back. 1, 2, 3, 4, yeah, that makes it 0.38 kilometers. All of a sudden, it's not such a big number anymore, right? 38,000 seemed like a lot, but no, not really. Okay, so we're going to put these two things together, and if I add that, I'm going to get 24.98 kilometers, right? When I add those two things together, yeah, that's right. Okay, so when we add units, they have to be the same. It has to be the same unit. Okay? Now, if somebody asks us to do something kind of weird, like let's add 2 liters plus 3 grams. Okay, now that doesn't make any sense whatsoever, right? I mean, those aren't even the same family, liters and grams. One is a measure of volume and the other is a measure of mass. So, I mean, we would have to really question that and throw that one out the window. I mean, you can't convert one to the other. Okay, so you can only convert within the same, I call it family, the same idea, length or volume or mass, but you can't go between multiple things, okay? All right, cool. So if we have to convert now between Celsius, I'm going to do temperatures here in a second, but between the English system and the metric system, we just again have to know a conversion factor to do that. And it just requires us to know those factors. Pardon me as I'm fumbling to get one here. Where is it in my book? They're just not everyday factors that we would have committed to memory. Okay, let's pull one out real quick here. Pardon me for fumbling. I thought I had it in my note and didn't. If I want to convert between the English or the British system and the system that we use, the conversions are really goofy, like meters to inches, okay? Meters to inches. Well, I'm looking at a table here. 1 meter equals 39.37 inches. Okay? We're not going to remember that, right? Even centimeters to inch, that's closer at least. 1 centimeter is 0.3937 inches. No one's going to remember that, right? Kilometer and a mile. 1 kilometer is 0.6214 miles. Okay? Not a very convenient unit. Okay? But what are you going to do? If we had to make that conversion, we've got 32 kilometers and I want to turn it into miles. Remember how we do it. We get this unit ratio. I might have 1 over 0.6214, or it might be the other way around. I got to think about it. km, kilometers. I got to think about it. I want miles, so I'm going to put the miles on the top up here. And I'm going to put the kilometer on the bottom there so that kilometers cancel. So now I need to take 32 times 0.6214. 32 times 0.6214 equals 19.8848. If I just write down all the decimals on my calculator, okay? So basically 20 miles, okay? That's how we would do a conversion like that. All right? I don't think you would ever be expected to remember those kind of conversion factors between metric and the English units because they're all goofy. Right? What about temperatures? Let's quickly talk that. We have more than 2 temperature scales out there, and if you're in the world of science, you'll use absolute scales like the Kelvin scale or the Rankine scale. But for most practical purposes, we use the Fahrenheit scale or the Celsius scale, right? And there's 2 little formulas that I don't think you would be expected to know. If I want to convert something from Fahrenheit to Celsius, here's the formula. Celsius equals, degrees Celsius equals the fraction 5/9 times my degrees Fahrenheit minus 32. Okay? And if I'm going back the other way, we could do a little algebra and shuffle it around and work it ourselves, but let me just write it for now. Degrees Fahrenheit is going to be 9/5 times degrees Celsius and then plus 32. Okay, so again, I don't think you'd be expected to know those 2 formulas, but let's use them. You might have to know how to use them. Let's do some common numbers, right? Boiling point of water at atmospheric pressure, we know it is 212 degrees Fahrenheit, right? What is it on the Celsius scale? Anybody know? Let's find out. Degrees Celsius equals 5/9 times 212 minus 32, and we just need to figure that out. Well, if I take 212 minus 32, I get 180, right? 5/9 times 180, okay? And if we work that number, what are we going to do? We're going to take 5 divided by 9 and then times 180. Oh, what do we get? 100. Okay? So 100 degrees Celsius is the same as 212 degrees Fahrenheit, okay, boiling point of water. How about the freezing point of water? Well, let's go backwards. Let me do it the other way. The freezing point of water in the Celsius scale is 0 degrees, okay? So I'm going to put in 0 degrees 0 degrees Celsius, and I want to know what is the Fahrenheit temperature. Now we know the freezing point of water is 32, right? But let's calculate it. So I want to know degrees Fahrenheit equals 9/5 times 0 degrees Celsius plus 32, okay? So that 9/5 times 0 is just 0, so 32. Okay, so if you didn't know, freezing point of water, 0 degrees Celsius, is the same thing as 32 degrees Fahrenheit. Okay, boiling point 0 and 212. So the Celsius scale was created based on water, right? Freezing point of water we call 0. Boiling point of water we call 100. That's two nice, pretty numbers, right, that we can reference in life, and that's how that scale was created. I forget how the Fahrenheit was created. Okay, but in order to go between the two, those are your two formulas that you might be expected to deal with, okay? And it's pretty simple. All right, so that's metric. Converting from metric back to our British or English system, it requires us to have a conversion factor, and we just have to know how to use it like any other conversion. All right, that concludes all our new material, or lecture material, I should say. What I would do right now, if this were a regular class, is I would hand out a practice test. So I'm attaching this practice test number 3. It's going to be attached on Blackboard for you to either print out or at least open and look at. And what I would do, like I said, right now in class, I'd say, all right, class, let's take 45 minutes and you work on that exam. I think it's 45 minutes is the time limit. And then we would go over it together. Okay? So obviously I'm not going to sit here for 45 minutes and do nothing, but the next video you will see me working through that exam. It'll probably take 2 videos to get it completely done, and then that'll truly be the end of the course then, okay? So do the exam before watching me do it, okay? Sounds good. Thanks.